Chapter 2, Lesson 8 is solving inequalities in one variable. So today we're going to be talking about the end behavior of odd and even functions. So we need to think about what the end behavior looks like on odd functions versus even functions, and also what happens when you add a negative leading coefficient. So the thing to remember about even functions, end behavior is if the leading coefficient is positive, both ends up, both ends of the function up. If it is negative, both ends down. And for odd functions, if the leading coefficient is positive, the left side down and right side up. I should be calling them ends, not sides. And if the leading coefficient is negative, it's reversed. Left end up, right end down. We're going to have to find the zeros of the functions by using our rational zeros theorem or synthetic division or factoring. For the multiplicity of the zeros, if the multiplicity of the zero is even, we know that our function will not cross the y-axis, or the x-axis, excuse me. And if it's odd, it will cross the x-axis. So that means if you have a zero, the multiplicity of the zero just means if the zero repeats itself, so let's say we go to factor it and we get x minus 3, so x minus 3 is squared. That would be an even multiplicity of the zero, so it like happens twice. Then we know that our function will not cross the x-axis. So if I have x minus 3 squared, I know that this function would be sitting on the axis at 3, but it would not cross it. However, if the multiplicity of the zeros is odd, meaning that it only happens once, or maybe it happens 3 times, then it would be crossing the x-axis at that point. Finding out where the function is positive, negative, etc., is we're going to make our sign chart on our number line, putting our zeros in there, and we're going to figure out where our substituting in our values. If the function is negative, we know that it's below the x-axis, and we know that it's positive when it's above the x-axis, so we'll be able to do that too based on our zeros. So this one says, if the function is x plus 3, x squared plus 1, and x minus 4 squared, determine the number of real zeros. First of all, our zeros would be negative 3 if I solved that one. This one, if I subtract 1 and then try to square root, it'd be plus or minus I, so that's not a real zero. And then the last one be at positive 4 with a multiplicity of 2, so we know it's not going to cross the axis at that point. So what I want to do here is make a sign chart with negative 3 and 4. I know that at 4 it is not going to change because it's not going to cross the x-axis, so the function is not going to change there. And if I would FOIL this all out, because I kind of need to know what kind of function it is, like if it's odd or even, if I was able to FOIL this all out and distribute this all out, I'd have x squared and another x squared, and x to the first. So it looks to me like this is going to be an odd function. So I know that one end will be going, the left end will be going pointed down and the right end will be pointing up. Also because it doesn't have a negative leading coefficient, so I know it's my basic. So it'll be negative up until -3. Then it will become positive because the multiplicity of -3 is odd. There's only one of them, so it's going to cross the axis there. And then it will not cross the axis again at 4 because its multiplicity is even, so it will stay positive. So just to check this, we can look at it in our calculator to make sure that we know what's going on here. So we have x plus 3, x squared plus 1, and x minus 4 squared. And zoom out a bit for you. That wasn't a very good zoom. There you can kind of see what's going on, but what we're really worried about is where is this function 0, negative, and positive, and we have to write our answers in interval notation. So it looks to me from negative infinity up until 3, this function is negative. And it is positive after that. So it's all below the x-axis only until -3, and then it's above the x-axis for the rest of it. And the zeros are 2 real zeros at -3, 0, and +4, 0, and 2 non-real at plus or minus I, 0. All right, this one says not to use the calculator. So what we're going to need to do here is try to figure out if we can factor this thing or what we can do here. So I'm going to do group factoring. I'm going to split it down the middle here. What do they have in common on the left-hand side is x squared. I'm going to go ahead and factor that out, and it's going to leave me with 2x minus 7. And the right side, they have in common just 2, I think. Which would leave me with 5x plus 12. No, that's not going to work very well because they don't have the same common factor there. So I guess I'm just going to have to try to find the zeros by using the rational roots theorem and figuring out which one of them is 0 by guess and check. So possible zeros here are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24, all over 1 and 2. So I'm just going to try, I don't want to waste a lot of your time. So I'm going to look here and find a 0. One, two, -2. Oops. Oops. Get me out of this thing. There. Now how to erase those. All right, so try -2 with my synthetic division. So I have 2, -7, -10, 24, drop the 2. 2 times -2 is, there we go, is -4. What am I doing here? Drop the -2. Drop the 2, which is -4 there, sorry. Add those to be -11. Multiply those to be +22. Add those to be +2. multiply those to be positive 12, multiply those to be negative 24, and that is a 0. Which leaves me with the quadratic 2x squared minus 11x minus plus 12 equals 0. So I know one of my zeros is x plus 2. I'm going to quadratic formula this real quick. 11 plus or minus the square root of 11 squared minus 4 times a times c, 25, all over 2 times 2, which is 4. 11 plus 5 divided by 4 would be 4. And 11 minus 5 is 6. Divided by 4 is 3 halves, which would be 2x minus 3. All right, so all of those have a multiplicity of 1. So they're all odd multiplicities. What order would they go in? Negative 2, positive 3 halves, and positive 4. And this is a cubic, so I know that the beginning and the end need to be opposite. And since it's a positive leading coefficient, I know it's going to start negative, sign change, sign change, sign change. Now the question here says, at what values is this greater than 0? Well, all of the values that it's positive. So between negative 2 and 3 halves, and from 4 to infinity. All right, this one says we can use our calculator. So first of all, let's set it equal to 0 so we can get this in the calculator. Plus 8x minus 2 is less than or equal to 0. X to the third minus 6x squared plus 8x minus 2. Looks like my zeros are .32. Well, instead of writing x equals, I'm just going to do this. 0.32. And 1.46. And 4.27. And it wants to know where is it less than or equal to 0. It's an odd with a positive leading coefficient. So I know it's going to start, sign change, sign change, sign change, because all those zeros have a odd multiplicity. And where is it less than or equal to 0? Looks like negative infinity up to 0.32 and between 1.46 and 4.27. Oh, and I just see that it's less than or equal to 0, so I need to change all of these to brackets. Did I miss brackets on this one? Nope. Good, that was just greater than 0. On this one, for rational inequalities, I need to find the zeros and the vertical asymptotes, and then use both on the number line. So, for the vertical asymptotes, remember we need to solve the denominator for 0. So I have 4 and negative 3 halves. And then whenever I want to be able to find the zeros, whenever I want to figure out wherever x equals the 0 is, I have to let y be 0. So I'm going to write 0 equals x minus 1 over 2x plus 3 times x minus 4. Change that into a fraction. Cross products gives me 0 equals x minus 1. And so I get x equals 1. Negative 3 halves, 1 and 4. This is a rational function here, so it's going to look a little bit different on our graph. So we have x minus 1. Because there's more than one thing in the numerator, it needs its own set of parentheses. And then I need an extra set of parentheses around the denominator because there's 2 of them. So I'm going to start with open, open, 2x plus 3, close, open, x minus 4, close, close. And you can see that the negative 3/2 and the positive 1 and the positive 4 for my zeros, and my vertical asymptotes are the ones at the negative 3/2 and the positive 4. And I need to know where is the function less than 0 and where is the function greater than 0. So it looks to me like the function is less than 0, the entire left-hand area of the graph there. So all the way up until that vertical asymptote of negative 3/2. So the function is less than 0 from negative infinity up until that vertical asymptote of negative 3/2. Then it looks like to me that it is above 0 until that 0 we found here of positive 1. So it is greater than 0 from that vertical asymptote until the 0 of 1. And then between there, it drops back down to be less than 0. So from 1 until 4. And then starting again at 4, it looks to me to be positive. So from 4 to infinity. We'll use the calculator here. We're looking at these vertical asymptotes, which we know are going to be x equals negative 2 and x equals positive 1. So we have 1 over x plus 2 being added to 2 over x minus 1. And we're looking this time only for where is the function greater than 0. So it looks to me like it's greater than 0 between the vertical asymptote there at negative 2 and the 0 that looks like it's at negative 1. And then it looks like, again, it's above the x-axis starting at that positive 1 asymptote until infinity. The last one here, we have 2x minus 1 times the square root of x plus 4. And we're looking at where is it less than 0. We've got a value there at half. And negative 4, which x cannot be here. So it looks like it is less than 0 from that negative 4 up until the half.